Hey Catalyst, I'm Sam. I'm the principal smart contract developer here at Ikigai. We've been working together with MLabs on the Hydra auction project, and I'm here today to show you the architecture and contracts that we've built so far. This video is specifically going through the relationship between the layer 1 and layer 2 and showing that off. It's not showing the more user-facing things like the front-end SDK and demo UI, which we'll be showing more of later. Let me start by giving some context for those of you who aren't already familiar with how the Hydra auction protocol works. Auctions always start on the layer 1, that is Cardano, but once the auction's been announced, it can be moved between the layer 1 and layer 2, Hydra, as needed for the best user experience. As a bidder, you will always start bidding by placing a deposit on the layer 1 in order to show good faith. The seller can then observe this deposit and choose to issue a credential to you as a bidder, which will allow you to bid on both layer 1 and layer 2, depending on where the auction is at the time. You do so by modifying a standing bid UTXO, which represents the highest amount that a bidder is willing to pay. But it doesn't include the actual funds for the bid. When the auction concludes, that standing bid UTXO determines who the winner is, and the winner must pay the amount that they said they would to claim the lot. If they don't, that deposit that they placed at the start of the auction gets returned to the seller as compensation for the time wasted. In this video, we'll demonstrate everything that needs to happen as part of the auction lifecycle that I just described. We'll start by starting up a demo server with multiple Hydra delegates in it to help facilitate the auction. Then we'll announce an auction. We'll place a deposit to register interest as a bidder. As the seller will observe those deposits, authorize them, and then start bidding. Then we'll move the auction from the layer 1 to the layer 2. We'll place bids on the layer 2 as the bidders that we registered. Then we'll observe the delegates close the head as the auction ends. And finally, as the winning bidder, we'll claim the lot. We're going to start by running make-serve in our Nix environment. This is just running a simple front end that we built for this demo specifically. What it's doing now is getting the seller's verification key in order to build the auction terms. Notice it's not asking for any funds when we sign. The second time we sign is when we're actually submitting the announced auction transaction. It's asking for 28 ADA because we're including a reference script in the auction metadata. Now we can inspect the auction info. We can see that the starting bid is 8 ADA, or 8 million Lovelace. We can also get the delegate information, which we need to be able to pass the auction into the layer 2. And we can copy the auction metadata transaction hash, which we'll be passing as a parameter to our delegate servers. After a few seconds, we get confirmation that the announced auction transaction has succeeded. This means we can now enroll in the auction as bidder by placing a deposit. This again follows the same two-signature flow, where we sign once when we're constructing the transaction, and then sign again when we're submitting it. Now, while we wait for that transaction to finish, if we scroll up, we'll see in the logs a couple useful functions that we made for the front-end utility. We've got find seller auctions, and we've got find all auctions. This will be great for switching between auctions and submitting transactions. Now we're finally to the fun part. We get to start working with Hydra. We return to our Nix environment and use our make delegate server script to start up 2 new delegate servers. We can connect to one of them directly with a WebSocket to get real-time information about an auction. Once we make that connection, we're immediately prompted to authorize this new bidder whose deposit has been detected. This time the first signature is for generating the authorization certificate, and the second one is for signing the transaction to send that certificate. Let's check back in on our Hydra delegates. We can see that they've moved the head state to initializing. This means that they're ready to start the auction whenever. This isn't a result of the authorized bidding transaction that we just submitted. It's an automatic process that happens when we reach the start of the bidding window. Just a few more seconds, and we get confirmation of the authorized bidder transaction. With it, the bidder gets prompted to sign. This is adding his signature to the certificate the seller sent to create a unique signature that allows him to bid. Now, acting as the seller, we press the Start Bidding button and can see the transaction constructing in the console. No double signatures here. We just need to sign once to submit the transaction. Once we receive confirmation on that transaction, the auction is officially open for bidding. We can also trigger a move to Hydra by sending a request to one of the delegates to move to Layer 2. Returning to our delegates, we can see the one we submitted our request to submitting a commit to move the standing bid onto the Layer 2. This is followed shortly by our second delegate. We don't have to worry about these could not commit collateral errors, since they occur after we've already submitted our commits. After another short delay, we can see that the collect.com transaction has been submitted, moving the Hydra state to open. This change in head status, as well as the current status of the standing bid, is broadcast to all clients connected via the WebSocket. Ready to see how fast a Hydra transaction can be? Let's place and sign a bid for 8 ADA, the minimum amount for the auction, and see how quickly it shows up. It's there before we can even switch tabs. For demonstration purposes, let's place a couple more bids. We'll start with a 12 ADA bid. This one should go through just fine, since it's higher than the existing bid. We can see here that the bid went through, and that the updated standing bid amount is being transmitted to the users via the WebSocket. Now let's try bidding 8 ADA to see what happens when a lower bid is submitted. As expected, the transaction fails. Okay, time for one more bid just to show that it's still working. We'll bid 15 ADA this time. Going down into the datum, we can see that the standing bid amount did again increase, this time to 15 ADA. Going back to the WebSocket output, we can see 3 outputs, one for each bid as it increased the standing bid. Okay, now that we have all our bids placed, let's skip ahead in time to the close of the auction to see how everything resolves. Here we are roughly 20 minutes later. You can see that the bidding time has expired. There was a brief mishap with peers desyncing, but in spite of that, we should see the head closing at any moment. In fact, there it is right now. With the head closing, we're now entering a contestation period of roughly a minute, where delegates are able to contest the results of the head if they disagree with them. While we wait for that, let's reconnect our WebSocket to the peer that desynced briefly. We can see that the head status is now being displayed as closed through the WebSocket as well. Skipping ahead just under a minute, the contestation period should be close to an end. Now we can see the fan-out possible head status has appeared. This shows that the contestation period is over, and we're now able to move the auction back to the Layer 1. Immediately, we see the delegates begin to initiate that process. Before the terminal closes, we see the head status gets moved to final. This means that the standing bid has been moved back to the Layer 1, and we can now interact with it there. Now, acting as the winner, we use the demo front end to create the claim auction lot transaction. You can see it building in the console on the right here. This transaction not only sends the lot to the winner, it also pays out the winning bid amount to the seller. However, because we're using the same wallet both as the winner and the seller, the transaction summary that we just signed only shows the ADA required for fees. We can still see in the standing bid that we're interacting with that the winning bid was 15 ADA. And if we weren't using the same wallet for the seller and the winner, those 15 ADA would be sent in this transaction as well. Now all that's left to do is wait for this transaction to finish on the layer 1, and we'll be done. Another time skip of about 30 seconds, and we can see now that the transaction succeeded. The auction has resolved. Let's take a look at what's in that transaction. I want to draw your attention to the second, third, and fifth outputs on the right here. The first one is the output to the seller. He gets 9 ADA, not 15. That's because the other 6 ADA are going to the delegates. Each delegate has a delegate fee of 3 ADA. 2 delegates means 6 ADA to run this auction. Lastly, that fifth output is the output of the lot to the winner. In an ordinary auction, there would be a few more deposits left around that would need to be collected by the losing bidders, but those collections can be done at any time and aren't strictly part of the auction lifecycle itself. Thanks for sticking with me. If you'd like to learn more, all of this work is done entirely open source under the MLabs Haskell GitHub organization. That includes extensive documentation. Please feel free to reach out if you have any questions. That's it for now. I'll be back in the next milestone to demonstrate our analytics and our demo UI. See you then.